In question 6, part E, we have a circle here, okay. A, B, C, D lie on the circle center O, and angle ADC, this angle here is 128, angle ACD is 28, this angle, okay, and angle BCO 30, BCO, this angle, okay. In part 1, show that obtuse angle AOC equals 104. AOC, this angle here, okay, this angle at center equals 104. Give a reason for each step of your working. Okay, it's very easy to solve this question. Okay, we know this because of these 4 points A, B, C, D lie on the circle. So this polygon here, or quadrilateral A, B, C, D, is a cyclic quadrilateral, and we know in any cyclic quadrilateral the opposite, each two opposite angles add up to 180. So we can find that this angle here, angle ABC, equals 180 minus this 128. So we can write here that angle, a measure of angle ABC equals 180 minus 128. This will be 52 degrees, and to give a reason for this, we can write here a cyclic quadrilateral, okay. And here this angle 52, okay, this angle ABC, angle at circumference, and the angle AOC is twice this angle because the two angles are subtended by the same arc or the same segment here, segment AC, okay. So angle at center is twice angle at circumference, so we can find here, or we can write that measure of angle AOC equals 52 times 2 equals 104 as required. And to give a reason, we can write that angle at center is twice angle at circumference, okay. In the next part, find angle BAO. Angle BAO, this angle here, BAO, this angle needed, okay. Sorry. Okay, we know that this big angle, angle BAD, okay, is the opposite angle of this big angle here at circumference, angle BCD, okay. And we know that the two angles, these two big angles, add up to 180 because of this cyclic quadrilateral, okay. So if we know this angle here, we can start our solution, okay. We know this angle is 104, okay, angle AOC, and this triangle AOC is an isosceles triangle, so we can find these two angles here, okay. We can reduce 180 by 104, okay, and this 76 we will distribute equally by these two angles because these two angles are equal, this isosceles triangle. So 76 divided by 2 equals 38. So this angle here 38, and also this angle 38, okay. And we will go to this triangle ADC. ADC, we already know these two angles, so it's easy to find the size of this angle here. We can 180 minus 1 28 plus 28 is equal to 24. So this angle here is 24. Okay, now we will add up these three angles. Okay, and we need to write this. Okay, measure of angle BCD, this angle at circumference equals this will be 28. Okay, 28 plus 38 plus 30 is equals 96. Okay, 96. So the big angle here, angle BAD, is equal 180 minus this 96. Okay, we will write this here, measure of angle BAD equals 180 minus 96. Okay, 180 minus this answer is for 84. Okay, so 84, this big angle here is 84, so we can subtract 24 and subtract 38 from this 84. Okay, 84 is here, minus 24 minus 38, this equals 22. Okay, 84 minus 38 minus 24 is 22 here. Okay, and the next question, find angle ABD. ABD, this is a small angle here. Okay, this one, angle ABD. This angle ABD is angle at circumference. Okay, and it's subtended by the segment AD, this segment here, or this chord AD. Okay, and the same chord or the same segment subtended another angle here in the circumference or at circumference. This angle ACD is 28. So ABD equal ACD is 28. Okay, in this part, the radius OC of the circle is 9.6 centimeter. Calculate the total perimeter of the sector OADC. Sector OADC is here. Okay, OADC, this sector here. Okay, the sector subtended between radius and an arc. Okay, we already know the radius is 9.6 and another radius 9.6. Okay, so we need to know the length of this arc ADC. Okay, this arc ADC is the opposite arc of us angle at center is 104, so it's easy to find the length of this arc. So to find the perimeter of total sector, we will add 9.6 for this AO plus another 9.6 OC, or we can write it as like that, 9.6 times 2, then plus, okay, the length of the arc equals the formula of the perimeter of a full circle is 2 times pi times r. R is the radius, is 9.6, we already know, and don't forget to multiply by the opposite angle at center, 104 divided by 360. Okay, this we will calculate it here, 9.6 times 2 plus 2 times pi times 9.6, okay, times 104 over 360 is equal 36.6, okay, for 1 decimal place. In part B, this diagram shows two mathematically similar solid metal prisms, okay. The volume of the smaller prism is 648 centimeter cubed and the volume of the larger prism is 2187 centimeter cubed, and the area of the cross section of the smaller prism is 36 centimeter squared. In part 1, calculate the area of the cross section of the larger prism. Okay, we know here the volumes of the two prisms. We can write it like that. This is the volume here, 648, okay, to the volume of the larger 2187. If we want to convert this cubic quantities to normal length, okay, we will take the cubic root, okay, for two numbers, and cubic root is same to make a power of 1 over 3, right? So this one we will make it power 1/3 and this one also power 1/3. Now it's length, okay, and we are talking about area here, so we want to convert this ratio of length to a ratio of area, so we will make power 2 for two numbers. Now the area, okay, 648 to power 1/3. If we make it to power 2, it will be 648 power 2 over 3, right? And this one will be 2187 to power 2 over 3 also, okay? Now we will use this ratio of area here to find the area of the cross section of the larger prism. We know the cross section of the smaller prism is 36. We will write it here, 36, and here we can write x, okay? So to find this value of x, the area of the cross section of the larger prism, we will multiply 36 by this number and then divide by this, okay? So x here equals 36 times 2187 to power 2/3 over 648 to power 2/3, and this, if we make it in the calculator, okay, I already made it here for you, okay, this will be 81, okay. So the area of the cross section of the larger prism is 81, okay. In this part, the larger prism is melted down into a sphere, okay. The larger prism, we know the volume 2187, okay, and it's already melted into a sphere, okay. Calculate the radius of the sphere, and we are given here the volume of the sphere, okay. This 4/3 pi r cubed actually will be equal the value of the volume of the larger prism is 2187. So we can write 4 over 3 times pi times r cubed is equal to 187. So to find the volume of r, okay, r to power 3 will be equal to 2187 divided by 4/3 times pi, okay. This for r power 3. So if we want to find the value of r, we will take the cubic root of this expression, okay, 2187 over 4/3 times pi. This is all under the cubic root like that. Okay, 2187 over 4/3 times pi. Okay, this will be 8.05. okay, 8.05. okay.